Hi guys, welcome to Pepcoding. So in this video we are going to discuss our next question of our series, searching and sorting series. So my question is maximum in the configuration. So in the previous question we have we have discussed how to find the maximum summation for this I into A of I, right? So similarly in this question we also have to find the maximum summation for I into A of I, right? But in the previous question we were allowed to have allowed to rearrange the array elements, but in this question we are not allowed to do so. The only operation allowed here is to rotate clockwise or counterclockwise the array in any numbers times, right? Okay, so let's discuss. Suppose this is my array. This is my array. Okay, let's say it has 8 4 8 4 2 1 and here is equals to 4. So I can have 0 rotation, that is equal to 8 4 2 1, or I can have 1 rotation, so my array become 1 8 4 2. If I rotate by 2, so my array become 2 1 8 4. If I have 3 rotation, in the third rotation my array become equals to 4 2 1 8, and in the fourth rotation my array become again 8 4 2 1, so which is equal to S0, right? So here we'll be having 4 states. So now let's check the summation for this, like the value of the value of ARR of I into I for this S0. So for this it will be equal to 0 plus 4 plus 2 into 2, that is 4, plus 1 into 3, that is equal to 3. It will be 11. Here it will be 8 plus 8 plus 6, which is equal to 22. Here it will be equal to 1 plus, it was 8 here, okay, it was 0 here, okay, 0 plus 1 plus 8 into 2, that is 16, plus 4 into 3 is equals to 12. So it will be equal to what? 29. Now again, if I do so, it will be equal to 0 plus 2 plus 2 plus 8 into 2, that is 8 into 3, that is equal to 24. So it will be equal to 28. Okay, right? So here my max sum is equal to 29. All right. So now let's discuss it on again. Let's discuss again it on another example. That will be, let's say I create another example. Yeah, let's say I make another array. It is A, B, C, D, E. Yeah, n is equals to 5. Okay, 2 3 4. Okay, so here my S0 will be equal to what? Sum of S0 will be equal to what? 0A plus 1B plus 2C plus 3D plus 4E, right? Now again here my sum for after one rotation will be equal to what? 0E 1A 2B 3C plus 4D, right? For S2 it will be equal to what? 0D 1E plus 2A 3B plus 4C. For S3 it will be equal to what? 0C 1D 2E 3A plus 4B, right? Now for S4 it will be equal to what? 0B 1C 2D 3E plus 4A. And again in the fifth rotation it become again equal to 0A plus 1B plus 2C plus 3D plus 4E, right? So as you can see here, the coefficient is here is increased by 1, right? So index here is increased by 1, right? So if I Like if I see from S0 to S1, my coefficient is increased by 1, right? My index is increased by 1, right? So if I say my sum is equals to, my sum for this array will be what? AB plus CD E, C plus D plus E, right? A plus B plus C plus D plus E. And now my S0 is equal to this 0A plus 1B plus 2C plus 3D plus 4E. Yeah, right? So from here, as you can see, if I add both of this, I am somewhat nearly equal to S1, right? Let's see. A plus 2B plus 3C plus 4D plus 5B, right? Which is nearly equal to S1. But now here we'll see that 5E, it has 5E, but it has 0E, right? So from, as I can say, as it is cyclic, this 5 is nearly equal to, is almost equal to 0E. This 5 is not 5E, actually it is 0E, right? Because this is in a cyclic order. So whenever you have something at index, we have something at n is equals as equal to n, and so f is, if I have something at index at position n, then it is nearly equal to 0th position, right? So this should be equal to 0. So from how can I make this to 0? Because in S1 I want it to be 0, right? So I will do what? I will add both of this and subtract n into ARR of n minus 1 minus I, right? Because n here is equals to 5, multiply by AR of n minus 1 is what, 4, and I here was 0 for this. So it will be equal to AR of 4. AR of 4 is what, E. So this cancel this, so it become equals to 0E. Now my answer is equals to S1, exactly as S1, right? Now similarly, if I have to find S2 using S1, how will I do that? I will find S2, I'll add S1 to the sum and again do the same, n multiplied by ARR of n minus 1 minus 1, because I here is equals to 1, because for s is equal to 2, for 2 I should be equal to what, 1, right? So here it will become, let's calculate this. My s1 was equal to what, a plus 2b plus 3c plus 4d plus 0e, and my sum is equal to a plus b plus c plus d plus e. So it will be equal to what, 2a plus 3b plus 4c plus 5d plus e, right? Now in the second rotation, my d should be equal to 0. So now d should have a coefficient of 0, but it has 5d. So now again I will do what? I will do here, I will subtract n into ARR of n minus 1 minus I. I here is equal to 1. For a for 2, my I should be equal to what, 1. So 5 into AR of n minus 2, n is 5. So AR of 3 is d. So I cancel 5d here. So I get answer, that is E plus 2a plus 3b plus 4c and 0d. 0d. Right? Okay. So from here we generate a formula, that is to find s of I plus 1. Sorry. That is to find s of I plus 1. What do we do? What do we have to do? Okay. What do we have to do to find s of I plus 1? To find s of I plus 1, we have to add sum to the s of I and subtract n multiplied by ARR of n minus 1 minus I, right? So this is my formula. So what do I have to have initially? I should have S0. I have to calculate S0 and sum. With the help of S0, I can calculate S1, right? With the help of S0 and sum, I can calculate S1. With the help of S0, with the help of S1 and sum, I can calculate S2, right? So this will be my basic formula that will be using it, right? Using here. So now let's code for this. Okay. So here, first of all, I will be having a sum variable. and S0. Okay. Now I will be calculating this for int I is equals to 0. I should be less than arr dot length I plus plus sum plus equal to arr of I and s of 0 plus equals to I multiplied by arr of I, right? Okay. Now we will have a max which will be equal to S0. Let's say max is equals to S0 and int Si is also equals to, let's say, S0. Okay. Now for int I is equals to 0, I less than arr dot length minus 1 I plus plus. Why am I running this loop till n minus 1? Because if I say my n is equals to 5, right? So I will have to run this loop till 3, because with the help of 3 I am going to find out Si plus 1. So if this loop runs till 3, so I can find out S of 4, right? So we are having here S0, S1, S2, S3 and S4. So I have to run this loop till S3 only, because if I'm able to calculate S3, I can calculate S4 easily, right? Okay, so here my sum will be equal to, in let's make Si plus 1 will be equal to what? Si plus sum minus n into arr of n minus 1 minus I. Okay, and I will have, now my Si will be become equal to what? Si plus 1, right? My Si will be updated. Now if my max is less than Si plus 1, then update my max to Si plus 1. Max will be equal to what? Si plus 1. Okay, and will return what? Max. Return max. Okay, yeah, and let's try to wait. Let me just erase this. Okay, now let's try to submit this. I'm getting some errors, that is cannot find symbol int SIP1. Wait, SI. Cannot find symbol int SIP1 is equals to int. Okay, so it should be arr dot length minus 1, because we haven't calculated it n here. So arr dot length, it should be arr dot length, that is equals to n. And now let's try to submit this. Now I again cannot find simple where n into arr dot length. Yeah, it should also be equals to arr dot length, that is equal to n, right? I haven't found it n here accepted, and let's try to submit this. Correct. Now here my arr dot length is equal to what? My arr dot length is number of elements, that is equals to n. So I have not extract n is equals to arr dot length, so I'm using arr dot length here. Okay, so that's why it was showing me an error. So I hope I made it clear to you guys, and I hope you enjoyed my video, and I hope you like this video. So if you like this video, please like, share and comment, and thanks for watching.